Hello, everyone. Welcome back. So today we want to talk about solving equations by factoring. So first off, I'm assuming that you understand first kind of basics of factoring polynomials. It'll be helpful. But after that, then our goals are to be able to write an equation in factor form if possible. We can't factor everything. Once in factor form, be able to solve the equation. That's what we want to explain today is how to do that. Let's take a look. Here's basic our procedure, how to solve by factoring. With that procedure, we'll explain how this works. So first, set one side of the equation equal to 0. And you're probably familiar with doing that. It's kind of like what you do when you solve a quadratic equation. Next, factor the non-zero side. Once again, note, not all equations can be factored. Some things we can't factor, or at least not factor in a useful way. Then divide both sides by any constant factor. So there's like a constant factor we'll be able to take out of everything. Just get rid of it by dividing through by both sides. It's not going to affect the solution either way, but it's just kind of helpful to get it out of the way. And how we're going to solve, so it says set each factor equal to 0 and solve. Okay. We're using this property right here that if you have two numbers, a and b, and you multiply them together, if a times b equals 0, what that tells you is either a is 0 or b is 0, or they're both 0, because 0 times anything is 0. So we're going to do then, if we get this as a true statement, and we'll see some examples, see how this works, then we want to find the values that make a or b 0. Those then will be our solutions to the entire equation, because those are what will give us a true statement here. Also, note this works if we have more than two factors. We'll see an example like that as well. So you have as many factors as you want, as long as they're all multiplied together equals 0, you can do this. And also, this only works if it's equal to 0, not if it's equal to some other number. Okay, so let's take a look at our first example. And first, we'll just do a very basic one. It's already in factored form to explain how this works. So number one, let's say we have this. Let's say we have x plus 2 times x minus 1 is equal to 0. Okay, this is already in factored form. So the idea here is, since these two things are multiplied together, these two factors, if either one is 0, it'll give you a true statement. 0 times anything is 0. So what we want to do now is find the values of x, which is going to make each one of these factors 0. That's what will give us a true statement. So what we do then is set each factor to 0. And solve. We want to find which makes each factor 0. So we have x plus 2 is equal to 0. And x minus 1 is equal to 0. Okay, and these are easy to solve. So we get that x is equal to -2 and x is equal to 1. Okay, and those are our solutions, both of those. Because we plug those in, for example, plug in -2 here to this one, we plug it in both at the same time, it will make this factor 0 since -2 plus 2 is 0. You plug 1 in for both x's, and this factor that makes this one 0 because 1 minus 1 is 0. So these both gives the true statement. So let me make that a little bit shorter. Now, also let me mention one thing. This is also true in general. I'll say, but, you know, if you have something like this, let's say x plus 2 times x minus 1 is, say, 1, any other number besides 0, this doesn't work. If this happens, then doing, well, let me simply say it doesn't work. So you don't set each one of these equal to 1 or anything like that. The problem with that is they're essentially too many solutions. It just doesn't work that way. So it's only when they're equal to 0. If it's equal to some constant, this procedure doesn't work. So what you have to do in that case, if you did have an equation like this, then you would actually have to essentially multiply this through and still get one side equal to 0. Multiply this through, get one side equal to 0. Get a new polynomial and try to factor that. You can factor that, then you could do it that way. One side has to be equal to 0, not any other constant. Okay, so now let's look at a second example. So number 2, let's say we have this. So 2 times x squared minus 8 is, well, first let's go ahead and make this equal to 8. Okay. Now, in this side, so let's get one side equal to 0. So subtract 8 from both sides, and that will give us 2x squared minus 8 is equal to 0. Okay. Now, factor out the 2. Okay, that's a common factor. So if we take out the 2, then we're left with x squared minus 4. Okay. Now, what I do here then is, once again, so we set one side equal to 0, factor the non-zero sides. Actually, this is not quite factored, so we need to finish factoring it. Notice this is, we can factor using difference of squares. And so then we factor that, and that's going to be 2 times x plus 2 times x minus 2 is equal to 0. Okay, now that's completely factored. Now, one other thing, as I said, let's also divide both sides by any constant function. So what we're going to do is we divide both sides by 2. And that just gets the 2 out of the way. Because actually the 2 doesn't play a part. Since it's a constant, it can't be 0. So we just get rid of that. And then what we have left then, of course, 0 divided by 2 is 0. So that gives us x plus 2 times x minus 2 is equal to 0. And now we have an expression like the first one we started with. Okay, so in the same way, since this is equal to 0 and these things are multiplied together, if either factor is 0, it makes the whole thing 0. So I want to find out which will make each one 0. So set each one equal to 0. So if x plus 2 is 0 and x minus 2 is 0, and just then solve each one of those, x is equal to negative 2 and x is equal to positive 2. And those are our solutions. So if you see, if you plug in negative 2 in both places, negative 2 will make this first factor 0, which will give you 0 equals 0. Plug in 2 to both, make the second factor 0, which will give you 0 equals 0. So both these are solutions to the original equation. And also, that's not the only way to solve that. So this is one way to solve it. Okay. Number 3. So let's say we have this. So let's say we have x to the okay, hang on just a minute. So yeah, x to the 4th, double check what I had, minus x cubed minus 20 x squared is 0. Okay, this is already set equal to 0. Make this look a bit better on this side. So now what we want to do is factor. If you notice, we have a common factor of x squared. Let's take that out first. And if you take that out, what we have left is x squared here minus x minus 20. Okay, taking a common factor of x squared, and then still factor again, keep factoring. This trinomial, we can actually factor it into x squared, and then once again, assuming you have some experience with factoring, then this will factor into x minus 5 and x plus 4. Of course, you can check that if you want. Just multiply back out, make sure you get what we started with. Now, you notice in the previous one, we divided both sides through by 2, which is a constant. Okay. We don't do that here since x squared is a variable. Okay, it's only if it's a constant we divide both sides. The goal is to find out what's going to make this 0. So if we divide both sides by that, essentially it's like dividing by 0 in a sense. So only divide both sides when it's a constant. Make this 4 look better. Okay, now Once again, set each factor equal to 0, including this one. So we have 3 this time. X squared equals 0. X minus 5 equals 0. And x plus 4 equals 0. Okay, set each one equal to 0. So here, the first one, use what's called the square root property. Basically, it's like taking the square root of both sides. So what it would say is if x squared is equal to 0, then x is equal to plus or minus the square root of 0. We know the square root of 0 is 0, and 0 is not plus or minus. It doesn't have a sign, so it's simply 0. That's one solution. You can see that if you make this, multiply 0 by this side, you get 0 on the, multiply 0, make x 0, this whole side becomes 0, which gives you a true statement. Then the rest work like the others. So here x is equal to 5, x is equal to negative 4. In this case, we have 3 solutions. And here they are. Okay. Now, this last part, this one, I'll do one more, is also based on what I said at the bottom, since the procedure works if there are more than 2 factors. We just saw one like that. We had 3 factors. Let's do one more quick one. Let's say we have one that's already in factored form, which is x plus 2, x minus 3, and x plus 3. So let's say you had this already in factored form. One side is equal to 0. So my point here is that as long as you're multiplying things together, then this procedure works no matter how many factors you have. Okay, so here you set each one of your 3 factors equal to 0. X plus 2 is 0. X minus 3 is 0. And x plus 3 is 0. You write this 3 a bit better. And so do the same thing. Solve each one of these equations. And so our solutions are x equals negative 2, x equals positive 3, and x equals negative 3. In this case, those are our 3 solutions. This is how you solve by factoring. And one final thing, not everything can be factored. Let me just mention one more problem. Let's say we had this. Let's say we had x squared minus x plus 50 is 0. Okay. Turns out you could try, but this actually, you can't factor this with real numbers. So it might be possible to factor with complex numbers using I, but can't factor this with real numbers. So in that case, you have to solve it some other way. Since this is a quadratic equation, for example, you just use the quadratic formula. So just remember that not everything can be factored. So you have to, in this case, you have to solve. Best thing to do is just solve with the quadratic formula. So just remember, not everything can be factored, but if it can be factored, you can set one aside equal to 0. Then if you can factor that, you can solve it this way. Okay, so what we learned then are basically how to, the procedure to, if you can solve by factoring, to do it, set equal to 0. One side equals 0. Then if you can solve the factor of the other side, like we've done here, you can use this. But if not, we have to use another method. Thank you. Have a good day.